Okay, this is a Hardy Weinberg question from a Biol 4 paper in June 11. So a quick read. It's talking about sea otters here. Saying they're close to extinction. Ban on hunting. Population begins to increase. Science tends to do two alleles of a gene in one population of the otters. The dominant allele T, coded for an enzyme. The other allele, little t, is recessive and doesn't produce a functional enzyme. So in the population of sea otters, the allele frequency for T, little t, was found to be 0.2. So use Hardy Weinberg, so you've got to put the equations down to calculate the percentage of homozygous recessive sea otters in the population and show your workings. Well, the first thing I'm going to do is put down P plus Q equals 1, and then P squared plus 2PQ plus Q squared equals 1. Just a reminder, P and Q are talking about the frequency of the alleles in the population. P squared, 2PQ and Q squared are the frequencies of the genotypes in the population. P squared, the dominant homozygotes, 2PQ, the heterozygotes, Q squared, the recessive homozygotes. What sort of information have we been given? Well, we've been given the recessive allele T to be 0.2. So that's Q, so that equals 0.2. We've got to calculate the homozygous recessive sea otters, so that's Q squared. So what we need to do is square that. So 0.2 squared equals 0.04. Now, it actually tells you here to capture it as a percentage. Now, if you'd left your answer as 0.04, you'd have only got one of those marks. So what you needed to do is turn that to 4%. And the way you get from there to there, from a decimal to a percentage, is times by 100. Whilst it's here, we're just going to have a look at this quick question here. What does Hardy Weinberg principle predict about the frequency of the T allele after another 10 generations? Well, remember the key thing is Hardy Weinberg principle assumes that the allele frequencies stay the same. So you could have said stay the same, or just say, well, it's going to be 0.2 again.